The next thing I wanted to do is to basically introduce Albert and Miroslav as the next ones that are going to be presenting.
Hello, Albert. Hi. So, as Jan said, we had the opportunity to have a talk by Albert Ziegler, who is actually one of the people behind GitHub Copilot. So, unless you've been living on a different planet and you haven't heard about Copilot, it's the thing that is going to change the way we look at programming, and we finally become software engineers and designers and no longer coders. So Albert, and we'll talk a bit at the beginning of cool things about the GPT-4 models and how GitHub Copilot evolves. And then after a while, I will switch to show you some demo how it actually works in practice in the tools and repositories that you could have in your GitHub repository. So Albert, principal engineer at GitHub Next, is the guy who has the coolest toys on the planet today, at least as far as I know. Albert, the floor is yours.
And thank you for the opportunity to speak here. As Miro said, I work at GitHub Next, which is kind of GitHub's speculative R&D department. So we try to look beyond the horizon and whatever we find there, pull it into reality. As such, I was part of the team that co-wrote GitHub Copilot. And I mean, we went public with that 2 years ago. And since then, I think it's now an uncontroversial fact that large language models have really proven themselves to be amazingly, well, let's say potentialful for code. So GitHub Copilot is a tool that helps you, well, enter new code in your IDE, basically. And then there's things like ChatGPT that many people use to help them code. And generally, there's a broad consensus that large language models are great. I mean, doesn't mean that they're trivial to use or that it's automatically safe to use them or anything. But there is potential if you can take it out the right way. And I think there's 3 reasons why they are so great at code. First of all, code is strings, and that is a language like strings, which is their bread and butter. The training data is plentiful. I mean, GitHub alone has like 80, 90 million developers, and they're all writing software or code or whatever. Not only OpenAI, who we partner with, but also many others are using that data and training models on it. Large language models, such as GPT, they need a lot of training data, but for code, they also have it. Now, this part is also true for natural language. There's also a lot of natural language out there. However, code has an advantage over natural language. That is, it's much more objective. Meaning that when you have a large language model producing producing prose, basically, that prose is kind of a black box. However, code is very much not a black box. You can statically analyze it. You can look at its call graph. You can look at its AST, whatever. You can, in the highest iteration, even run code, which means that there's ways for code LLMs to iterate and to benchmark and also to grade their output and make it usable in ways that doesn't exist for natural language, which makes AI great at coding, which is cool. But in fact, that's not exactly what we want, because creating new code is only a tiny, tiny, tiny part of the software development cycle. So in software development, first of all, most time that you spend in your IDE, you're not writing new code files, you're refactoring existing code. But more than that, code files do not exist in isolation. In fact, the concept of a code file in isolation, source file in isolation, doesn't even make a lot of sense. It's about code bases, and those come with history, with commits, and with bug reports that you're working on. You might work on issues, you might discuss. Of course, a collaboration like PRs and project boards. But all that still obeys has the same the basic principle that also held for code. It's string-based. And that is extremely useful. I don't think there's another part of human industrial activity that is string-based to such an amount as software development. I mean, in particular, open source software development quite often is like properly purely string-based, but also industrial software development is very, very heavily string biased, at least. And again, the training data for all that is plentiful. There's terabytes of code on GitHub. But if you add like the whole history of the commits and then pull requests, it's even more. And just as code, software is objective. In a sense, it's maybe even more objective, meaning that last slide I said that you can run software, that you can run code. That's actually not true. You cannot run code. What you can run is a code base. You can run the software, which comes with its installation instructions, with its Docker containers, with its dependencies, and with the whole code base. While you cannot run a file in isolation, usually, you can typically run a code base, a software project. And all this means LLMs should be a great match for aiding not just the process of writing code, but the whole process of software development, which is in a very small part adding new code, and but really consists of a multitude of activities. Nevertheless, after GitHub Copilot came out, like for 2 years, there was not a lot of not a lot of large-scale activity. And the reason for that is that there are also particular challenges. And I think they can mainly be grouped into 2 bits, which is software development is an extremely varied activity. It's got many, many facets to it, which are all different. And software, as in software projects, are huge. So let's address both of them. First of all, software is varied, meaning that there's many, many different tasks that you have in software development. And just because a model is good at predicting code in a finished code file, that means it has potential. That means it must understand something about code. But the thing that it understands does not literally give you the answer to the question that you have in software development. If you want to make a tool for fixing bugs, then the tool that you have for writing code needs to be made to fit. And the good news here is that this is an extremely fertile emerging field, that of prompt crafting or prompt engineering, that is extremely fast evolving and that deals with these problems. So they all follow like a general pipeline of you have a problem that you want to solve with AI. How do you pose a question to the model in such a way that the most likely continuation to the question, so with what an LLM gives you, is either something that enriches your context, and then you can have a multi-step process where you go around again and again, or is something that you can transform into your solution. The other problem is that software code bases are so incredibly huge. And here it's mainly a question of, in that slide I had just here, I had this context that you get for each problem to be solved with AI. That is often relatively large in natural language applications, but in software applications, it is usually gigantic because the software project that usually has a code base with many thousands of files, it might be tens of thousands, millions in extreme cases. Each of the files have hundreds of lines. It's gigantic, and that's just the current state of the code base. If you look at applications that are supposed to help you with, say, bug solving, you will probably also need the bug report, past bug reports, the commits that happened in the near future that made the bug appear, error traces, and so on. So the amount of context that you do have is gigantic, but large language models, despite the name large, have a very limited have a limited context window of things that they can think of at the same time. So they're a bit like goldfish. When we started GitHub Copilot, the Codex model that we used to feed it, it had a context window of 2,000 tokens. And yes, that has improved and will continue to improve by quite a factor. So only this week, day before yesterday, OpenAI announced that their GPT Turbo, which is kind of like the standard good version of their code-capable LLM, has now a context window of 16K. And that's great. But it is a drop in the bucket compared with a whole code base. And even if someday someone finds a way to reliably train LLMs that have an infinite context window, even then you would still be somehow constrained by size, because it's difficult to pick out the right pieces of information out of a gigantic context, and the processing of that prompt that costs time and compute. So you need to somehow deal with it. And again, the good news is that there are techniques emerging that are very capable of dealing with these limitations. When we first went online with Copilot, what we just did was we take context that we like and that we like most to push that into the prompt, and all the rest we just ignore that doesn't fit. But other projects at Next, and I'm sure elsewhere, they use techniques like you summarize one file, and then give in another pass, you give the AI the summaries of all the files in the folder, and then you summarize the folder. And with those hierarchical summarizations, which all like in this cycle go from problem to resolve with AI, are of the form that not trying to give you a solution, but to give you more and more compact, in this case, context. So all those things can help the LLM build up a kind of 360 vision of your whole software project. And for most software applications, such a 360 vision, or something approaching it at least, is really needed. Another alternative to just hierarchical summarization is purposeful elision. So giving as much context as you can, but not more than you have budget for, basically. So that looks a bit like this. That's easier to demo than the hierarchical summarization. So I want to try to actually show something. Okay, you see a code file here. It's a TypeScript like a deep database wrapper. It's just a toy, but it has like 50 lines or so. And let's say we want to, we believe that an LLM can use the input or the contents of that file. And we have some reason to believe that a particular part of the file matters. Maybe that's because the user's cursor is in that file right now, which actually is the case. Or maybe it is because that is the part that has most recently been changed, or that bug report error exception has pointed ourselves to. Okay, so what do? We can't fit the whole file in context because we also wanted to communicate other things. So probably what we would like to make is a prompt a bit like the following. So we have reason to believe the comment is important. So definitely we keep that comment. We keep as much of the context as we can. So previous imports and that defined interface. And of the following class, that is much too big to fit into the context. I mean, in this example where I allow myself 201 tokens. It should be 200 anyways. What the serendipitous way of informing the LLM of as much as possible would be to probably add the names of the methods, but then cut away their bodies. However, if, for example, you want to focus on a different file, then you should give that function in detail and have of the others as much as you can say. And the whole thing is dynamic and fast. And if you happen to have more context, then you can include more and more. And if you happen to have very little context, well, then you can only include a tiny bit. So apply this to several files, and then suddenly in much less tokens than you have for your context window, you can actually communicate quite a bit about the code base. And that is important for many things. If I find my slides again. There they are. Okay. And I think this is the point where I give over to Miro.
Very, very important activity in working with those language models, as you saw, because whatever we feed to them, they know and understand as a context. And by the end of the day, they only predict one word at a time, right? So this picture is essentially the same picture that Albert showed, but I'm a professor, so I'm a bit more pedagogical in that and a bit more organized and much older. So I need to understand it as well. But if you look at the kind of things that we get from the model, the language model essentially only predicts words, and it does it in a loop, right? So at the very top, you have a model that we have trained for one of the projects in Software Center, which is going to predict, or which we essentially use to recognize design patterns. So we train it on a large corpus of data, which was prepared to be a bit more sensitive to the word and the pattern of a singleton. And if you see at the top, I ask it to fill the mask, so add the word. What would be the next word of that? And then you see at the highest probabilities that the next token will be F. And if you look at the training data, the black data, well, F is the most common letter or token that pops up after the colon in the word singleton, right? So it essentially does this kind of thing. But then what if I can do even more? What if I can provide more context, but as Albert said, from very different things, not only the code, but also the comments and the tests and the pull request and so on. I could actually do a lot of more cool things than even ChatGPT. So what we could do is, in the loop, for example, we could have my function on the test that I've written. We could use the prompt compression that Albert talked about, add some smart things about testing, and tell the model that what we are after is testing, and then what we could get is the test like this. Now, this test is, of course, not perfect. There are a few things that one would have to fix over there, but it's a very good test to begin with. So let me show you how that actually looks like in practice on a demo. We'll see if the demo actually works. So this is my repository that Albert provided me with a link to the Copilot. So to that repository, there is a bot called Copilot for PRs that's linked in. So whenever I do a PR, I can ask the bot to do something for me. So let me create a PR, see if that's going to work. I'm not going to very advanced thing. I took the code from Rosetta Code for a quick search. I just paste it in, and then I commit the changes. I will create a new branch with a commit request and see what's happens here, right? And that's perfect. Then I have this commit, create pull request. And what I can do now is I can tell Copilot something like this. Copilot generate tests. So I can just comment, I want the Copilot to generate tests. Now what happens is, hopefully it will happen. You see those two eyes? Now Copilot started looking at my code. It's analyzing it in the middle over here in the progress. Will take a few seconds. And after the analysis, it will tell me that I'm missing test cases for new functions. And not even that, it will tell me what kind of test cases I could start with. And this is, of course, a very, very simple function, so it sort of goes very fast. I will show you an example of a bit more complex code. And if I go over here, it says, make neat test, right? So Copilot realized that, okay, I have one file that didn't contain any unit tests, so that could be good. And I could go to details even. And then you see the bot actually tells me, well, look, if you want me, I can suggest you some tests for this file, right? So I could click on suggest test. It goes for a minute. Right, I could refresh. And then suddenly it tells me, look, I've generated some test cases. I created a commit for that with this. So if I click on this, I could see that now this is my test file that was previously generated by Copilot as well, now contains a lot of tests for that quicksort algorithm, right? And I can, of course, do even more. I can, whatever, I could write OK and comment on it. I could submit this to the main branch and even test it. But I'm not going to go through all of that, because you may say, well, OK, but this is a quicksort, so everybody knows how to test sorting algorithm. It's an extremely simple example, right? And I chose that example because I wanted to make sure that this demo will actually work today. But I also want to show you a bit more complex example of how this actually worked. So in this software, what I do is we have, this is the project of, that we do together with Grundfos, where we use the language model, among others, Codex as well, to recognize cybersecurity violations in the code. So this tool is a more advanced pipeline, but it has one element that it's supposed to be modular. So I could plug in all kinds of models into that, and then they should work over here. And in my previous commits, I actually did plug in one of the models over here, which was tested by, or designed by us and tested before in Outline, but I didn't commit any tests. And this is the kind of test that Copilot for PR started to generate, right? So it generated, for example, the test, since we work with embeddings, it generated a test that tests the actual embedding functions, whether we do calculate the distances correctly or not. Now, I, of course, am very sure that my function was correct, so I didn't need testing. But this way is actually not a really bad way of testing this kind of functions, because I was actually not really testing and thinking about testing these simple things. But this kind of thing is actually providing with the testing. And then, of course, it tests all kinds of things. You see small and big ones, and test calculating distances. So you see, it can generate quite complex test cases based on what I'm doing, right? And the only thing that it got was essentially a very small file which contained some of the code that we wrote before. So this is the file that was checked in and modified. It's a file that contains, I don't know how many lines of code, 300 lines of code. So it's not that big file. But somehow, thanks to the prompt compression and thanks to the context that was provided by the tool, it understood that I wanted to generate test cases based on that, and that it also generated test cases that actually make sense. As I said, it's not always perfect. One has to put some effort afterwards to see if the test cases make sense. Maybe we could add something or remove something. But as a very beginning, it's a really powerful tool. Imagine that if I were to write this test case file before, this one, with about 100 lines of code and so many assertions, it would take me probably half a day or even more to start coming up with examples and so on. Now I just got it by saying Copilot generate test. And with that, I will finish up, because I think that Copilot and this kind of tools are really shifting our focus as software engineers from low-level programming issues and thinking about low-level solutions and generating test cases to suddenly becoming really engineers and designers and architects. What it also changes is the way we have to think about, for example, controlling or monitoring the progress of software development. For instance, the concept of code coverage in test cases and unit test cases will now stop making any sense whatsoever, right? Because the tools will generate test cases for us. So the only percentage of code coverage will be less than 100%. But there will be fewer and fewer projects that will have less than 100% code coverage, right? So we need to find new ways of working with test cases. But the low-level test case generation, and even very, very smart test generation, will shift our focus to actually thinking about how to test the software, not how to write a test case. With that, I will finish up. I leave over to Albert again for questions and comments. You can put Albert on the screen again. So thank you very much for that. Thanks, Albert, for the demo. I think we can take a question on two, yeah? Right, Jan? Yes, Wolfgang.
How do I do this that Albert hears me? Maybe you have to tell him.
I'm sorry?
Albert will not hear my question, will he?
I will repeat your question to Albert. You hear me, Albert, right? Yeah. So.
Thanks for a very nice presentation, both of you. I have a question.
Mike. Yeah, microphone guy is behind me. I just speak, Wolfgang.
I just speak, okay. So, thank you very much. I have a question, a rather specific question, and I don't know who of you should answer it. And that is when it comes to test generation, which you talked about in the end. Test generation, you're solving two problems which are very different. One is the test inputs, code coverage, and so on. You can look a lot at the code and get a lot of insights on how you should choose your test inputs. The other is the test oracle, right? And there it is. It can be quite problematic to be very aware of what the code actually does because the oracle should not just reproduce what the code does, but what it should do. So, and I'm not expecting you to solve that problem entirely, but what is your take on that?
Yeah, that's a very good question. Before I let Albert answer, I could tell you that, for example, in my test case with the leap year, so the test case was actually so good that it found a mistake in my code, but it also contained a mistake by itself, right? For example, in the very initial suggestion I got, year 2003 was considered to be a leap year. And 2003 by no means is a leap year, and since we've lived through that, we know it wasn't. Right, so I fully agree with you. There are things that one has to think about when it comes to Oracle. But again, I think that it's a technology of the future. I mean, it will just be solved. So, Albert, do you want to comment?
Yeah, so thanks for that question. Yeah, so I'm aware that traditionally there's like in test generation, there's this Oracle input to problem divide. We're actually the way we're doing this under the hood does not follow that separation, and that's by design. First of all, because that separation is very, very useful for automatic generation, but not necessarily exactly how people think when they're writing code. And the LLM mirrors people's thought patterns better than the theoretical clean way. Also, there's different reasons for having tests, like many different reasons. But the one that you mentioned with if you give it the code, which we very much do, and then we have a test, then that just freezes the functionality. And if there is an error in your functionality, if that error is not so glaring that like the software basically balks at writing a test for something that wrong, then that error will be frozen. That is true. Because finding bugs is just one reason for tests. Another one is tests are kind of a guardrail that prevent people from changing your code or what you consider the critical parts of your code and of your features, and prevent regressions. That was the main effort we were looking at. However, as you said, it does mean that tests can pass by mistake, and that's true. And ideally, we'll address it better. But at the moment, we're mostly focusing on the freeze functionality as it is right now, in a readable way, in contrast to many other test tools.
Great, thank you.
Thank you very much.
Thanks. I still think that this is the technology that's the best thing since the sliced bread. So, I have one more question, Molly, over there, and then Jonathan, I think, had a question as well.
Yeah. So it seems like the limit on how big your prompt can be, is that more of an API limit than anything else? In which case, has there been any sort of experimentation with doing like parallel, like sort of divide and conquer approaches to certain questions that you have. So rather than, try and stuff everything into a single prompt, you divide up your code base into discrete parts, with some sort of technique, and then send multiple API calls and then merge them?
Yes, absolutely. Yes, this is an API problem in the sense that the model will not take more than however many. I mean, 32 for DB4, in fact, 32K tokens for one call. But you can definitely have a situation, and you do, where you make several calls to the API, and some of them are for the explicit aim of summarizing, and some of them are for the aim of getting intermediate results. This test generation that Miro demoed, it made I don't know how many calls to the API, but a couple of calls to the API. And other parts of this Copilot for PRs project, which I should add, so the tool Miro demoed, that's not public yet. For other parts of this project, we already have a tech preview that's public. And those parts, some of them, almost all of them, actually do use this divide and conquer summarization technique that you sketched, actually, where you have several things and several that it might be files or that might be changes to files, and you ask the model to summarize them in a shorter bit, and this is what you then use for your prompt at the next level. And depending on how much context you have, you might have to have several layers of this hierarchy of consecutive summarization.
Thank you.
I should add that, like, for proper, a 360-degree vision of your code base, you also need a way to get back and zoom in again, because for example, for test generation, you need to know not just what happens in a file, but for some files, you need to know very, very explicitly what exactly happens. So what exactly the code is supposed to be, in which order you pass in your arguments or something like that, or you can't code against that.
Thank you, and we take last final question from Jonathan.
Yes,
Make it a good one.
Yeah, thank you very much. Very interesting talk. I have a question regarding intellectual property rights, really, because I know there's been a lot of discussions with these AI models in general, but also for GitHub Copilot about, basically intellectual property right infringements and such things. I think there's been people saying, oh, you need to have some sort of a way to credit the correct person or whatever who wrote that piece of code. And I was just wondering, broadly, your thoughts on those concerns, and if there's any sort of ideas how to address those from a technical standpoint. Yeah.
So, I mean, first of all, I'm not an expert on this. So I'll give you some thoughts, but without any aspiration to completeness. So I think it's typically considered like a undesirable situation if code is created by an LLM that has already been created before, let's say. It's technically extremely difficult to find out not only when that happens, but in particular where this creation has occurred for the first time, because because it's not just difficult for an LLM. I mean, take a piece of code that you see on Stack Overflow and ask yourself the question, where has this been written for the first time and by whom? And then you can try to Google and search GitHub, and everyone has copied around different snippets of it, because you will not get such a regurgitation unless it's something that's appears either very commonly in the training set, or is completely trivial in a sense that it's the only way to write it, basically. So addressing that technically is very difficult. The way that Copilot, to the best of my knowledge, I should say, I'm not I'm at GitHub next, and then we've handed over Copilot to a production team. But the way that Copilot deals with that is that it indexes the training set and basically either suppresses or flags or whatever completions that look too similar to something that already exists in the training set, which seems like a sensible solution to me. And I certainly don't know any better, because otherwise I would tell them.
Thank you very much. Then I think with that, we'll leave over to Mikael, who will take the next presentation. So thank you, Albert, very much for being with us, and hopefully you will be back again. Thank you.